household bleach contains 6% sodium hypochlorite. How much household bleach should be mixed with 70 liters of a weaker 1% sodium hypochlorite solution to form a solution that is 2.5% sodium hypochlorite? Okay, that sounds complicated, but basically what you have here is you have X liters of this 6% solution. You don't know how much that is, so you're just going to call it X. And then you have 70 liters of this weaker solution, so 70 liters of the 1% solution. And when you pour those two amounts into a bucket, you want to end up with a 2.5% solution. So before we even start talking about percentages of sodium hypochlorite, we can just talk about liters of solution, liters of liquid. You are pouring in X liters of the 6% solution, and you're pouring in 70 liters of the 1% solution, so you have X plus 70 liters of solution once you do that, because that's what you have. And we want that solution to be 2.5% sodium hypochlorite. So here's a picture of what we're doing. We've got a bucket of 6% solution. We've got a bucket of 1% solution. We're going to pour some of each one into another bucket so that we end up with a 2.5% solution. We're going to pour in X liters of the 6% solution. We're going to pour in 70 liters of the 1% solution, which means we'll end up with X plus 70 liters in the third bucket. All right, so we can use all that information right there to write an equation just about sodium hypochlorite. So how much sodium hypochlorite are we getting from the first bucket? Well, it would be 6% or 0.06 of those liters, and those liters, there are X of them. So that's the sodium hypochlorite from the first bucket. From the second bucket, we're getting 70 liters, and 0.01 of those 70 liters, since it's a 1% solution, are sodium hypochlorite. And then in the final bucket, we want 2.5% of that to be sodium hypochlorite. So that is going to be 0.025 times those liters, X plus 70, is sodium hypochlorite. So sodium hypochlorite plus some more sodium hypochlorite is equal to the final amount of sodium hypochlorite. So now we just need to solve for X. So I would probably just multiply this whole thing through by 1,000 so that I can get rid of all these decimals. So that's going to be 60X plus 700 equals 25X plus 1,750. So that is going to be 30 liters of the 6% solution. That is what you would add to the 70 liters of the 1% solution to end up with 100 liters of the 2.5% solution. Okay, uniform motion, rate times time equals distance. Anytime I do one of these problems, I like to just write rate times time equals distance. This is how I organize my data from this problem. There are two situations here. So Donna participated in a 41-mile biathlon, which included running and cycling. She spent an hour and 45 minutes on the bike, and she spent 45 minutes running. Her average speed on the bike, was 12 miles per hour faster than her average speed running. And the total distance of the whole biathlon is in the first sentence, and it just says 41 miles. So we have biking and running. All right, let's look at the rates. It says that her average speed on the bike was 12 miles per hour faster than running. So if we call that rate X, then the bike will be X plus 12 miles per hour. The time for the biking was an hour and 45 minutes, and I'm just going to say that's 1 hour and 3/4. So 1.75 hours for that time. And for the running, it was 45 minutes, so that's 3/4 of an hour, so 0.75. And then, like I said, the distance is a total distance of 41 miles. So over here for distance, I'm going to do rate times time. So here we've got the time, and we're multiplying that by the rate for the bike. And then over here, we're multiplying rate times time for the running, and that's the distance. If we add up those distances, we will get 41 miles. And then we will just solve for x, and that will tell us the speed for running, and then we can add 12 to that to get the speed for biking, and that would be all we'd have to do. So I think you can finish that problem. Rates of work, still the same type of problem. Rate times time equals work. So at a mail order company, Derek can process 100 orders in 4 hours. So Derek's rate of work is going to be 100 orders in 4 hours. And we could actually write that as 25 orders per hour. Miguel can process 100 orders in 3 hours. So that's 100 orders in 3 hours. So basically 100 over 3 orders per hour. All right, and it says, it's asking how long would it take them working together to process 100 orders. All right, so remember, rate times time equals work. And so we have Derek's rate, which is 25 orders per hour, so 25. And his time, we don't know what it is. That's what we're looking for. And then Miguel's rate is 100 over 3. And his time is going to be the same as Derek's. They're working together. So they're just working in the same time. So 25x and 100 over 3x. If I add those up, I want to get 100 for part A. So part A, 25x plus 100 over 3x, we want that equal to 100. So we would multiply that out. We would solve for x, and we would find out how long it would take. And then for part B, same exact information, same exact stuff, except that this time we want to see how long it takes them to do 1,400 orders. So still same rates that they had before, and that would equal 1,400, and then you would solve for x to find out how many hours that would take. Proportions, it says in a jury pool there are 8 more men than women. If the ratio of men to women is 8 to 7, determine the number of men and women in the pool. All right, so the first thing they tell you is that there are 8 more men than women. So there are more men. So I will call the number of women x, and the number of men then will be 8 more than that, or x plus 8. And it says that the ratio of men to women is 8 to 7, and a ratio is just a fraction. So men, x plus 8, over women, x, is equal to 8 over 7. And now I would just cross multiply, and I'd have 7x plus 56 is equal to 8x, and then solve for x, and you get x equals 56. So there are 56 women, and 8 more than that is going to be 64 men.